Okay, good morning. Expectations are rising. Glad to be here. I have to admit that I had to Google future trends of service-oriented computing, and Wikipedia wasn't much of a help, so I can't really tell you anything about future trends of computing. What I can tell you is about past trends in sewing machinery. So I'm going to talk about the sewing machine, which I found on the flea market. It caught my eye. I thought it was a beautiful thing, and I began to look into what's the special thing about it, because I had never seen it. Anybody seen this sewing machine? Anybody know? They usually kind of look different. At first I thought it was a kid's sewing machine. So then I found out that there's a story to this. And so this guy is James Edward Allen Gibbs, and he was a carpenter. He was born in 1829 in the hills of Virginia in the backwoods, and he didn't get around much. When he was 26, in a newspaper, he saw an ad for a recently discovered sewing machine. It was a Grover and Baker, except in that newspaper, he didn't see the whole picture. He only saw the upper part of that sewing machine. And, you know, being a curious person, he tried to find out, how does this thing work? So apparently there's a needle that goes through the cloth, and it has to retract through the same hole. So no way this machine can work the same way as a human sews. And there is nothing in that picture that indicates that there is another mechanism underneath with another thread underneath. So he kind of only in his mind thought, well, maybe it's, a single chain stitch thing. Something has to hold the thread underneath. And maybe it could be a rotating hook. And satisfied that he'd kind of found out how sewing machines work, he went back and, did his woodwork. And almost 2 years after, Gibbs went into town and saw an actual sewing machine. So he saw the full part of it, and he was shocked. It was huge, it was loud, it was unreliable. You had to readjust it every couple of stitches, and it was dreadfully expensive. And that night he got home, took out his pocket knife, because he was a carpenter, and he actually crafted this wooden model of how a sewing machine could work. And then he went into town to get a patent on it, and he found a guy who helped him build a patent model. And they formed the Wilcox and Gibbs sewing machine company, and they eventually built this machine with tooling in Massachusetts. It was among the first machines that had interchangeable parts. It was half the price of the regular sewing machine, and it had this ingenious mechanism underneath where it catches the thread to sew, and he combined it with a transport, because he could use the same rotation to transport the cloth, which heretofore didn't exist. Wilcox and Gibbs was extremely successful. This was the machine. They couldn't meet demand. It's the most successful sewing machine model ever. Was built well into the 20th century. And look at that. If you look at that, it looks like a G, right? He even got his initials into this thing. So it's even a kind of a study in design. Why am I telling you this story? Because I love my machine, but also because there's a story in there about when a healthy dose of curiosity meets ignorance, interesting things can happen. So at first I wanted to talk about the future of ignorance, but I thought that was kind of, that's not. So it's curiosity with ignorance kind of tends to give this variety of ideas that lead to different implementations of things. And it's something that is interesting when we're thinking about working with kids, working with students, and also in our field. Like, this is Ivan, and Ivan Sutherland. Alan Kay always tells the story, like how he asked Ivan how he did it, that he came up, with windows and objects. And Alan tells the story like that Ivan says, I didn't know it was hard. So he fearlessly forged ahead and just did it. And likewise, my selection of heroes is limited. This is Dan Ingalls, who then later got built on Ivan's ideas to invent the GUI. And Dan will readily admit that he didn't know Lisp. So when he did Smalltalk, he didn't use Lisp, which would have been the natural thing to choose, but just invented it on his own and came up with really this new paradigm that is now the predominant paradigm of object-oriented programming. So in the spirit, really, of Dan Ingalls. I'm showing you this in this programming environment, which is the environment I'm working on, which is, I don't know anything about math, so I try to keep reinventing Scratch, which is a programming language that I feel comfortable about. And in the spirit of Dan, you know, since I'm not a computer scientist by profession, I thought, well, things have to be built that way, that first you build sort of an operating system that, you know, you have objects that you can directly manipulate. This is basically morphic. Then you kind of, you know, take other kind of widgets like a dial. You can, you know, attach them to something set, and now I can take this and kind of directly manipulate it. Kind of some interesting forms keep coming up, and on top of kind of building an operating system-like thing, I'm building this programming environment which is called Snap, and it looks very much like Scratch. In fact, it is Scratch, except with a couple of additions. It's got functions and first-class data structures. And this has been used for UC Berkeley's new course called The Beauty and Joy of Computing. It's not that new anymore. It's kind of in its 7th year. And it's really about having a non-intimidating, low-threshold introduction to computer science, something that looks exactly like Scratch, but in fact underneath has the semantics of scheme, or many of the semantics of scheme. And so one idea as we're teaching this to students, as we're using this with kids, is that often educators will say, you know, it's great to have, you know, these blocks here, but there are too many blocks. Like, it's only about 120, but, you know, when you're starting, it's like too many choices. And so one idea that's currently floating around also in Scratch is, what if we could have custom versions of this programming environment where we hide blocks so it doesn't get so difficult. So you only get the blocks that you need for a certain task. So let me hide, for example, the multiplication block. And that, in turn, kind of got me thinking about Gibbs, because he saw something and then he didn't see how it worked. So a nice kind of idea is to think about how could we, not having something, extrapolate from something we do have, to recreate it, to reinvent it, and maybe come up with different ideas. So in the case of you know, the multiplication block, I could try to kind of make a multiplication block, which would be A times B. And so I could say, okay, A is going to be an input, and B is going to be an input. And so now I want to do something. I guess I'm going to need if. And I'm just going to make this for positive integers. I'm going to say, you know, if B is 1, I'm going to report is our return. Oh, wait, that's stop. I'm going to report A. Otherwise, I'm going to report the sum of A plus, wait, now I need the block I'm already working on, plus A times B minus 1. Let's try that out. So now I should be able to do 3 plus 4 kind of works. So I can, by hiding blocks, I can kind of induce people to reinvent other blocks. So I thought, well, this is kind of fun, you know? It's kind of fun to build an environment where we can let people reinvent things that already exist. Because it's hard to, you know, invent totally new things, but there's benefit in learning things that already exist, and you kind of think, how does it work? So I thought, kind of, what's an interesting thing to hide, to try to reinvent? And kind of the one thing I was really afraid of was, what if somebody took away if and if else? So how, you know, what do I do now? I want to teach recursion. I don't have if. What am I going to do? So let's try to do if. Here's what I want to do a reporter version. It's going to be if test, then it's going to be true. That's going to be a false case. So test is going to be just a Boolean input. And true is going to be a case And I'm going to say it's unevaluated. Unevaluated changes the order of operations. Something, usually all the inputs are evaluated from left to right until the function is evaluated. In this case, I'm going to put the input unevaluated in there and just evaluate it inside. So this is the true case, and the false case is going to be the same. And let's do a test case. Here it is. So, I want to say, well, if it's true, say yay. I'll say nope, and now it's not doing anything because I didn't do something. So how would I do this? Which other block could I use to recreate if? And after some thinking, and I came up with several ideas, and kind of the one that I thought was kind of cute was there's another primitive in there that kind of does the same thing, and it's Boolean primitives. It's OR, because OR needs to be short-circuited. I thought, well, what if I could use OR? So, for example, I could have a list of, true and false, and I want, the first item of this, and I actually want to call this. So basically, this is what I would want to do. It should work. For now, I'm always getting yay, even though it's true and false. Now I basically need to convert my Boolean input to a number, and I don't have typecasting because it is strongly typed, even though not the variables, but the data structures themselves. So I thought, wait a minute, here's OR. The second case only gets evaluated if the first one is false. So, I should probably do something like this, like make a variable. This is a count. And I'm gonna, evaluate the count. First, I'm going to set it to 1. And now I should test it. And if it's not true, I guess I should have to change the count by 1 and then report the test. So I'm reifying this. And I'm calling it. Let's check it out. Now I've got, okay, I forgot a variable. Now I've got nope and yay. I just made myself a control structure from the idea of a Boolean operator. So a while ago, my colleague and I were in Vienna, and we showed this to some friends in Vienna, and there's a friend, I don't know if you know him, Erich Neuwirth, he's a statistician in Vienna, and he said, oh, this is great, Jens, what I'm missing in your language is the pipe operator. So he loves R, and there's apparently this thing Magritte, and it's allowed to pipe things into each other, something Fabio has showed us yesterday, similar to what he's working on. And I said, yeah, I know, pipe sounds great. I don't know anything about pipe. Explain to me what it is. And he said, oh, it's just it's a value, and then you have a sequence of monadic functions, and you just take the result of one and put it into the next one. I said, well, gee, let's find to reinvent this in Snap. So you said it's called pipe, a value through a set of functions. So the value obviously is a value, and the functions are going to be functions. And it's going to be multiple ones because it might be more than one. So this is basically it, right? Here's what it should look like, and then I can add things to it. So, okay, I could use my if block, I guess. Let's try this. So if the functions are empty, I'm just returning the value. Otherwise, well, what do I do now? Otherwise, I pipe something through all but the first of values. Oops, where'd it go? And what am I piping through? I'm calling the first one. I'm calling the first function. with the value. So let's try this. So here I got, Systeme, Anwendungen und Programme. And I want to turn this into an acronym. So the first thing I'd do is I'd split it. And in Snap, if you just leave a field empty, it is a parameter, really. So I'm splitting this by white space, and I'm getting an error. What am I doing wrong? An empty function, otherwise called, So now I'm getting kind of my first, I'm getting a list of all the words. And as a second thing, I would like to filter kind of for words that are short. So I'm going to, keep all, only the ones that are longer, whose letter is longer. Wait, the length, gosh, I got a new computer and I'm confused. My trackpad. The length is longer than 3. So let's try this. So now I want to take the first character. So the next step is going to be mapping. I'm going to map the first letter of this. So now I'm expecting a list of letters. And then I want to combine them again into a word. So I'm taking combine, which is basically reduce. And I'm putting in the join function. And now I'm getting SAP, yay. So I built myself a new control structure out of building the basic building blocks, kind of reinventing if, and reinventing a new syntax. I could do the same thing by just nesting these functions, but it's kind of neat to, if you think about how you see something and try to reinvent how it might work. And I have no idea whether pipe actually works that way in R or not, but the results are similar. So this is kind of the idea, to hide something and reinvent it, to find a new way, to find an alternative way how things work. And so when I'm working on this project at SAP, I'm trying to make it relevant to SAP. I'm trying to make SAP like this project. So I try to kind of, cover the bases, the messages that SAP wants to get out. And one of the messages is IoT. So everybody knows this device? It's a BBC microbit. It's a little inexpensive board that they've been giving away to every 11-year-old in the UK. And we've got a similar project in Germany. They basically forked the repo, calling it Calliope. So the idea is that you give this to kids, and kids program a computer by programming this thing. And they've got kind of these. Anybody programmed this? Anybody used? What did you use? Make code? Right, so the usual way you do this, you give them nice blocks-based environments, you put together some code, you have a simulator that you try it on, and then you compile it and download it on the thing. And we were thinking about, this is kind of sucky because you need to compile, link, run, and then you find out something is wrong, so we can rethink this. What we're trying to do is, we want to program this in a better way. And this is the prototype of something we are working on. When I say we, it's a project of John Maloney, Bernard Romagosa, and me. So we want to not have a simulator, but actually to program the thing live. So what we want to do is, I plug this in, and I connect it. Now I'm getting the blocks. It's called micro blocks, this project. I'm getting some things that I can do with this board. For example, here I've got this panel of LEDs, really, and I can draw something on it. And if I click on it, it works right away. I don't have to compile, link, run it. So here's another thing like the clear display. It should go away. So I can copy this. And I'm really bad at drawing, especially, oops. So now I should get a big heart. Yay, okay. So what if I stick this together, and I should probably wait. Oh wait, clear display should be down here. Like wait 100, is that, oops. Oh, I should wait some more. So as you can see, one of the interesting things is it's live. So there is no need to kind of, always debug it and download it again. So now I got a heartbeat. So I want to put this into a forever loop and also wait some more. Okay, it's blinking. Okay, while it is running, I'd like to only do it while, oh, look at this, there's some more to discover. Here's the button A pressed. If I press this, it's false. Now if I press this button here, it's true. Okay, maybe I put this in here, and now if I press this button, it's blinking. So this is nice. I'm live programming this thing here, but what if I want to run this autonomously? What if I don't have my laptop? So the vision is, this is now on this board. I unplug this thing, and I plug in the independent power source. And it's not working. Why isn't it working? Because my power source is broken? Oh, okay. I didn't start it. So I made a mistake. Let's replug it back in again. The program should notice that, yeah, I plugged it back in. I want to keep working on this. Let's add a start block. So now it's again working. Now let's disconnect it. And this is actually a valuable lesson because these mistakes happen. They happen to me. They sure happen to kids. So now I'm on an independent source and it's running on the board. So this is kind of the vision that, programming is something, we're teaching kids these notions that programming is something that you need to plan ahead very well, because if you don't plan ahead, you're going to fall on your nose. But the fact of the matter is, usually we don't plan ahead. I mean, we just try stuff, and later we tell the great story of how we planned ahead and how it all just worked. So really what we want to do is, give kids, stuff where they can tinker, and they can try things, and it doesn't break things. And once, they're done, they can show off their work. So this is the idea, really, of one of the visions that we kind of connect the term IoT with what we're doing with Snap to kind of bring that to meaning. Another thing is, data, working with data. And I don't have a very compelling example for that. But when I look at my sewing machine, it's got a serial number here. And I was kind of curious what the serial number means. And it turns out that the Smithsonian Institution has a database of, it's really just a file of kind of the first 20 years of the company, Wilcox and Gibbs, of the serial numbers. It's a CSV. And I put this into Snap. This is the data. So in order to kind of make sense of it in Snap, I guess I need to, split it. And then I want to, split every line, by the colon. So here's a file that gives me all the numbers. So I thought, wow, this is cool. Let me get the serial numbers, assign this. And now I can, I've got this thing that looks for the serial number in the file. So it's 262186, and I can find out that, yes, this machine was built in 1875. And another thing that's interesting is I can see the production numbers because they just had one model. So I can see the production numbers of Wilcox and Gibbs. So what if I, put these production numbers and plot them? So I'm getting this graph of how they performed. And I didn't know anything except it occurred to me that it's kind of interesting how this is a constant production, and then it ramps up. And apparently the reason is because demand was higher than they could supply. So they were kind of at full capacity running for years. And then they were really successful. And it occurred to me that, wow, what happened in 1873? Something happened in 1873. Production went down. I had no idea. Anybody has an idea? 1873, long ago. It was called the financial panic, apparently. There was a recession, Gründerkrach in German, and at the time, it lasted until the turn of the century. It was called the Great Depression, until a couple of years later, an even greater one came along to snatch the kind of title from the previous one. But, point is, even though there was a depression, Gibbs died a very rich man. He was very successful. The company existed well into the 20th century. And shortly before he died, he sort of shared his impression of what's the essence of his success was. And he said, kind of basically, no useful machine was ever invented by one man. First, it's all failure until somebody, and he attributes this to the mental power of himself, I guess, comes along to combine the ideas of others with his own to at least find something that is feasible. And I thought that was kind of interesting, because there's a bigger idea to reinventing. And maybe the bigger idea to reinventing is collaboration over time. Really reinventing something that somebody else has worked on is almost like together we're stronger than one. It's a kind of a collaboration that is deferred, that is asynchronous. And to totally drift off into hand-waving thing, another thing that that SAP is very adamant about that is going to be in the future is, artificial intelligence and machine learning. And yesterday we heard this Ex Machina talk about how maybe machines in the future, or maybe already, can get original thoughts or come up with creative ideas. And I'm thinking, well, maybe not, but maybe one way is to not make them smart, but to make them ignorant about certain things, kind of give them certain things and let them extrapolate, and maybe they find different ways through the maze for interesting ideas. So when I'm talking to people at SAP, and when I'm talking to kids, trying to show them what machine learning can be about. Last time you were involved of, we saw this user interface that somebody at SAP was working at, and they could basically do gestures on an iPad to perform certain tasks. And it occurred to me that yes, this is some form of machine learning. How can we make this tangible in Snap? So what I have here is really a little drawing program. And I put it up with something that my friend Yoshiki Yoshima told me a long time ago, the $1 gesture recognizer, which I didn't know. Yoshiki does it in every environment he makes. And I thought, well, if we connect this, here's the recognizer function. But what if you recognize something, and in this environment, you just broadcast what you found out. You just say, I found something, I recognize something, and then something else in that would say, oh, I know what to do with what you just found out. Then it could be interesting to kind of make programs with kids that actually make sense of what you draw. So here's kind of the idea of having a symbol that is actually recognized with meaning turned into an expression. And even nicer, kind of what if we could take what we draw and apply what we recognize to what we draw to make pictures come to life, and to use kind of this idea for storytelling. And that's kind of, when I show this to kids, they always like this method. We can make it rain, just a small gesture, and look what happens. And I tell you, yeah, this is the promise of computer science, make much with little, and, tell a story of how this technology is going to take us to new realms where, we're going to find out about what is in score. So maybe, we as humans are just going to build the building blocks. Oh wait, that's the wrong one. See, I didn't train it well. I guess it was only trained for this way. What if we humans, just program the building blocks, and the computers help us make them smart? And I guess one idea is, of course, they'll kill us all. AI is going to kill us all. a hope would be that maybe we can work together. Maybe we can collaborate, same way as Gibbs collaborated with Howe before him, to actually reinvent parts of what makes us human, to maybe even learn more about empathy ourselves, and to kind of take it to the next level. Thank you very much. I'm ready for some questions.